So Mary Ann, take it away.
All righty. Thank you, Scott. I am so happy to introduce Josie Gillard and Tom Cabot to the Portola Valley Sustainability Committee to speak with well-earned authority on best practices for home electrification. Both Josie and Tom are Menlo Park residents. They have both served on the Menlo Park Environmental Quality Commission, helping to pass one of the state's first city all-electric REACH codes. This critical transition to electricity is even more important as we experience at the gas pump and see in Europe the dire cost of relying on fossil fuels. Josie comes from a career in the solar industry and Tom from a career as a utility planner. Both have spent the last several years electrifying their own homes, doing real case studies on electrifying a variety of home types in San Mateo County and teaching people up and down the peninsula how they too can do a home electrification retrofit on a budget without upsizing their electrical panels. Thank you, Josie and Tom, for generously joining us tonight. We are so honored to have you.
Thank you so much. Well, thank you for inviting us. As you mentioned, Tom and I both served on our city's Environmental Quality Commission. Tom still does. And so we know the good work that these commissions do. So thank you all for serving and doing this good work for Portola Valley. I will go ahead and share my screen. We've got some slides here and Tom and I will just sort of go back and forth informally on the slides. Can everyone see my screen?
Yes.
Okay, super. All right, so we're going to talk about best practices and going from gas to electric at home. We'll focus on residential. Tom has done a little bit of work in multifamily, but mostly we're focused on single family residential. Obviously, there's also work to be done in the commercial space and for large multifamily buildings, but we'll focus on single family for tonight. Okay, so very high level, our agenda we'll go through just the basics of electrification, why electrify. I think Mary Ann gave some good, good reasons at the top of the meeting, but we'll go into a little bit more. We'll go through a home example. This is a home taken from a county case study that's being conducted on 10 homes across the county on what it takes to electrify homes. We'll look at the issue of panel space. A lot of people think they can't electrify on their existing panel, which is usually not true. We'll talk about that a little bit. Look at barriers, pitfalls to avoid when electrifying, and then end with some benefits of electrification. Okay, so what is building electrification? This diagram sort of calls out the different elements that we like to focus on. And they're labeled below 1 through 5. So number 1 is replacing a gas furnace with something called a heat pump, an air source heat pump. Generally around here, air source heat pumps make sense. Number 2, replacing a gas dryer, if you have one, with an electric or heat pump dryer. Number 3, replacing a gas range or gas cooktop with an induction or electric version. Number 4, replacing a gas water heater with a heat pump version, or in some cases, electric resistance. And then number 5, replacing your gasoline car with a non-fossil fuel alternative, which is for most people going to be an electric vehicle. We also throw in rooftop solar and batteries because rooftop solar can make the whole electrification process more affordable because solar electricity is much cheaper than grid electricity now. And then a battery can address some of the issues that, some of the concerns people have about reliability of the grid if they're going to convert their home to all electric. So batteries can help with that. Okay, Tom, you want to take this one?
Sure. So the issue of why electrify, and it, people kind of wonder about that, but the reason is that Peninsula Clean Energy, PCE, they're providing 100% carbon-free electricity already. It's their basic product is a mix of hydropower plus wind and solar power, and a little bit of geothermal. And then you can also upgrade by paying a cent per kilowatt hour more to 100% qualified renewables. So it kind of takes that large hydro component out of there and uses all wind and solar power and other renewables. And so anyway, anytime you add this new electric load to the grid, it kind of gets PCE to follow their policy to install more renewables. And so you're actually increasing the amount of renewables that get implemented in the state when you electrify. And then this will enable this quick transition away from fossil fuels, and it'll save energy and save money.
Okay, so I was doing a little bit of research. So the graph here just shows typical greenhouse gas emissions for cities on the peninsula. I was looking into Portola Valley's greenhouse gas inventory, and the most recent one I could find was 2005. So instead of showing you that one, I thought I would show you a more recent one from the city of Menlo Park. And having looked at greenhouse gas inventories for cities all across the peninsula, I can tell you this is very typical. So from city to city, there aren't a lot of differences, at least for kind of these smaller cities on the peninsula without a lot of big industry. So typically, and I would assume this would be the case for Portola Valley, about half of your emissions is going to be coming from vehicles. So that's gasoline, diesel, vehicles that are emitting carbon dioxide. About a third of your emissions probably are coming from natural gas in buildings. So natural gas is made up of methane, which is an extremely potent greenhouse gas. Compared to carbon dioxide, it has a global warming potential that's between 25 and 85 times greater than carbon dioxide. So anytime there's leaking from either gas inside your home or a gas pipeline or gas at the wellhead, it's really spiking those emissions, at least in the short term for us. So that's why there's been a lot of focus recently on how can we get rid of natural gas. The electricity emissions 10 years ago were much greater on for cities on the peninsula, but now that, as Tom mentioned, we've switched over to carbon-free electricity through Peninsula Clean Energy, the emissions from electricity in our buildings is a very small fraction generally of a city's emissions. And then waste is, again, another small wedge of this pie graph. And I did a little research because I was curious to see how did Portola Valley, because I know there's sort of a history of being green in Portola Valley. I was curious to see what the adoption rate of EVs. It's quite high, actually. So according to the CEC, the California Energy Commission, there's a really cool website that can show you this, and they update it quarterly. So if one of you is interested in kind of tracking this for your city, I'm happy to show you how to do that. But 12% of the cars that are registered in Portola Valley today are zero emission vehicles, most of them being EVs. I think there was one registered in the last year that was a fuel cell vehicle, but most of them are EVs. So there's good progress being made on the vehicle side, lowering emissions. We have lots of companies entering this space, marketing new vehicles. So we're seeing progress on that front. Unfortunately, we do not see progress on reducing natural gas in buildings. There's no exciting company like Tesla making a new heat pump that everyone's really excited about. And so we just don't have that. The technology is there, but we don't have that sort of public awareness and interest in switching to a new technology yet. Okay, so this is a graph showing, again, sort of the why. The IPCC, which is the Intergovernmental Panel on Climate Change, which is a group of hundreds of scientists who come together periodically to report out to the world on what's happening with climate change, have noted that we have, starting in 2020, we had a carbon emissions budget of about 400 gigatons. So that's 400 billion tons of carbon dioxide that we could emit before we pass the threshold of 1.5 degrees Celsius. So if you'll notice, the annual emissions globally is somewhere between 40 and 50 gigatons. So if you all can do the math of that, we have a budget of 400 gigatons and we're emitting 40 or 50 gigatons a year. That means starting in 2020, we had about 10 years of emitting at that rate before we go past 1.5 degrees Celsius of warming. So we're now 2 years into that. So we've got 7 or 8 years left to get our emissions down. And you can see that the trend globally is still up. So unfortunately, even if we were leveling that off, we'd still have a problem. But we really need to start getting it down. And that's the orange line, which is showing, what we'd have to do to emissions in order to keep below not just 1.5 degrees, but 2 degrees C of warming. And the little red dash line there is to show you that for every person in Portola Valley or Menlo Park who needs to replace their furnace this year, that furnace is likely to stay in use for about 30 years. So you can see that that sort of keeps steady an emission that needs to be dropping off very precipitously. So what does that say? We heard in the latest IPCC report that came out a week or two ago that we really can't install a single new fossil fuel device if we're hoping to stay under 2 degrees C. So anyway, that's the message here, which means we really need to get policy in place and get those gas appliances off the shelves if we're hoping to try to meet any of these targets. Okay, so here is the home that I mentioned, which is part of the county study that Marianne mentioned and has been a part of, sort of sanctioning at the county level. So 80 homes applied, 10 were selected, and those 10 homes are having electrification plans done, and contractors are bidding on the projects. And the idea is to see what does it take to electrify a home in San Mateo County, and we've chosen a variety of homes. And how much does that cost? What are the challenges? What are things that could be done to make it easier? So this home is a home in Redwood City. It's 1,900 square feet, 4 occupants. It was built in the 1960s. We thought it was sort of pretty typical, and it has a 100 amp panel. Many people consider that a small panel, but to Tom and me, that's a lot of space, and we can fit a lot of electrification on a 100 amp panel. All right, Tom, you want to walk them through panel optimization?
Yes, thanks, Josie. Yeah, so what we've been looking at is by studying different parts of the electrical code and looking at all the different new appliances available on the market, is that there are a lot of ways to just carefully pick the appliances you select for electrification by picking the more power efficient versions that use less wattage or amperage. And amps are a measure of current flow, watts are a measure of power, and they're proportional to each other at the same voltage. So by looking for the better equipment, you can do all of this electrification and stay within that 100 amp bounds, because this 100 amp panel can deliver 24 kilowatts of power, and that's about 33 horsepower. So there's a lot of delivery capability already on almost every home out in Portola Valley, and a lot of homes are at the 200 amp level. So by just making these careful choices, you can avoid the $5,000 cost of panel upsizing. And then Josie and I took a look at some of the data for this San Mateo County study that we're we're doing. We're both involved as volunteers on this study, doing the analysis on 10 homes. They're shown on the left that we're looking at electrifying, and their highest peak usage during the past 12 months of electric usage is shown in the blue bars, and the remaining space on their electric panels is shown in the green bars. And then Josie's and my homes are the two on the right. And we're both either, I think she's nearly all electric in her home, and my home's all electric, although we have 2 electric bikes and still drive a gas guzzling Prius. But once we get an EV, we'll bump that blue thing up just a little bit more, just because we don't need a very big charger, as you'll see later in the presentation, to go very far. Back to you, Josie.
Okay, yeah, so this is back to our home in Redwood City. I'm just going to show you a series of slides, and on the left is the existing appliance, and on the right is the appliance that we're recommending for the home. So here we have a 50-gallon gas water heater, which is pretty typical. It's in their garage, and we're recommending to replace it with a heat pump water heater, which I wrote uses 1/3 of the energy of the gas water heater, but I noticed down below it has a UEF of 4, so it could use 1/4 of the energy of the gas water heater. So a heat pump, as you all probably know, moves energy as opposed to creating it through combustion. So it's similar to the way a refrigerator moves heat out of the inside of the refrigerator back to the outside through the coils and venting that heat outside. A heat pump does the same thing. It's just moving heat, in this case, from your garage, or this family's garage, into the water in the tank. Even though it may feel cool in your garage, there's actually quite a bit of heat there that can be gathered, sort of like a sponge. So the heat pump water heater we're recommending here is a Rheem 80-gallon, 15-amp heat pump water heater. We really like the 15-amp water heaters as opposed to the 30-amp water heaters. Rheem makes both because it fits better on the panel. The fewer amps you can use, the better. The reason Rheem sells both is that 30-amp water heater has an extra resistance heater that if the heat pump isn't keeping up with the demand in the house, it can provide extra like boosting heat. But there's already one of those in this water heater. So we feel like around here, you really don't need 2. The other thing we do is we recommend upsizing the water heater from 50 gallons on the left to 80 gallons on the right. That will help address those any issues with running out of hot water. We also recommend installing a mixing valve, a thermostatic mixing valve, which basically allows you to set the temperature on the water heater, the heat pump water heater, higher than you would normally have it. Mix in cold water as it comes to your tap. So it's the temperature that you like it at the tap, but you're kind of rationing out that hotter water and making that tank last longer. Okay, so this family had an existing kind of older looking Trane air conditioner and a Bryant gas furnace inside in an interior closet. We're recommending that they replace those units with a heat pump system, a Mitsubishi 3-ton inverter driven heat pump system. The compressor on the left is the outside part that'll go where that big Trane kind of boxy looking thing is. And then the ducted air handler is the darker gray component with the Mitsubishi system, and that'll just drop right in where the gas furnace is. So in terms of impact on this family's kind of indoors or outdoors, there's basically no impact. The outside compressor will be much quieter. The Mitsubishi will be much quieter than the current Trane air conditioner compressor, and the footprint will be a little bit smaller. So this family has a large 48-inch gas range, and we were able to find an induction equivalent, which actually goes for about $2,000 less than the GenAir range on the left. So this range is an induction, and that means it doesn't use any gas, but it's very fast at heating up pots, heating up water, and the induction technology allows you to really dial in temperatures very precisely as well. So from a chef's perspective, this is a very good alternative to the gas on the left. So for clothes drying, this family already had a resistance electric clothes dryer, which interestingly, to me anyway, uses 22 amps of electricity at 240 volts. So that's actually more than that Mitsubishi heat pump that's going to heat the whole house. So these resistance dryers, the point is the resistance dryers actually use a lot of electricity and they're not super efficient. The heat pump version on the right is something that I own, and it's the same size as the standard American dryer. Some heat pump dryers are European style and they're smaller, but this one is kind of standard American size. But it uses 14 amps instead of the 22. So it just helps make space on your electric panel much more efficient, and helps on your utility bill. So for EV charging, we're recommending a wall box pulsar. We like wall box because you can adjust the current, and where the electrician adjusts it can help you kind of in your load the electrician's load calculations. It can help you stay underneath your threshold for maximum amps on your panel. So we find one of the biggest mistakes people make when they're electrifying is if the first thing they do is get an EV and install a level 2 EV charger, is they get a huge charger, like a 50 amp car charger. This is completely not necessary unless you drive like 200 to 300 miles a day. You don't need a charger that size. If, like me, you generally need maybe, max 100 miles of charge a night, then a 15 amp 240 volt car charger is plenty. So this wall box pulsar can be adjusted by the electrician and to help you stay on your panel. The budget option is something that I have actually, which is outside on my garage, this NEMA 6-15 outlet. And this cost about 20 bucks as opposed to the wall box on the left, which was several hundred. Tom, you want to take this one?
All right, thank you. So one of the, so far we've talked about using more efficient devices as the way to electrify and stay on the existing panel, but there's another technique also, and it's using more sophisticated controls on the devices so they take turns. And so shown here are 3 variations of those devices. On the left side is a circuit sharing device, and it allows one circuit to do 2 things. And the classic one is called Dryer Buddy or NeoCharge, and it plugs right into the outlet that most people have in their garage, say for an electric dryer, one of those big 240 volt dryers. And so the dryer plugs into one side of this little box and the car charger plugs in the other. And while you're drying clothes, the car charger pauses. And as soon as the clothes are done, the dryer shuts off and the little box automatically re-energizes the car charging. So that one takes turns between 2 devices. That shown in the middle is one brand of a circuit pausing device that can go between the panel and the device, and it has little measurement leads that measure how much power the whole panel's conveying. And when it gets to the panels, say 80% loaded or higher, it then pauses the car charger and waits till that big surge of usage is over. And so that surge of usage might be caused by something like, in the chat, we were talking about tankless electric resistance water heaters. So a small electric resistance water heater that tries to heat the water at the same time you're using it. And so that draws a lot of power. And so if you had one of those on your panel, then you might need one of these load circuit sharing or circuit pausing devices that would pause your car charger while you were showering and then let it back on again when there was more space on the panel. And then the extreme version of that is on the right, the smart electric panel. One brand is span.io, and then it's got a lot of different circuit breakers and analysis going on where you can rank order all your circuits and decide which ones are they most critical and they always get their power, and which ones have to pause if there's a need to conserve power and stay on. To keep the whole circuit breaker for the whole house from flipping.
Great, I'll jump back in here. So the other system that we are specifying for these homes to get quotes for the homeowners is a solar system and a battery system. Here, we're trying to max out their roof space and what can fit on a 100 amp panel, sort of the maximum solar roof system that can fit on 100 amp panels, so 5.8 kW system. And then here we were specifying a 20 kilowatt hour battery system, although a 10 kilowatt hour battery system would work just fine as well. And that would allow them to have critical loads during a power outage. Okay, some building shell improvements were necessary in order to get the house to that 3-ton heat pump HVAC sizing. So they have some insulation in their attic, but we're recommending they really boost that insulation in the attic, and then also put some insulation in their crawl space below the floor, and then also do some duct repair work. So with those extra measures, we think they're going to be just fine and comfortable with a 3-ton HVAC system. Tom.
Yeah, thanks, Josie. So shown in this bar graph, it's a horizontal bar graph showing the range of panel power needs for different types of devices in these 5 categories shown. So the top category there is 5 different versions of clothes dryers and how much panel capacity they need. And that top one that doesn't need any more panel capacity is a combined washer dryer. It's one machine that does the washing and then the drying. And so in a way, that machine just takes turns doing the 2 tasks. And so you don't have to visit it in between to move the wet clothes over. But then the other ones at the bottom of the stack of that top 5 is the resistance, the very common electric resistance dryer that more than 50% of all households already have. And so that one uses more power, but in between are heat pump versions, and Josie's got the one second to the bottom there, it's a hybrid. It's got both resistance and heat pump for different modes, so it can drive fast or power efficient. It takes its pick. The second little batch there is the microwave oven. And it's funny, if it's sitting on the counter plugged into one of the counter circuits, it doesn't count in the panel calculations. But if it's built in to the range hood or something like that, attached to the house, it does count that little bit. The middle block there is different cooking alternatives. And the smallest one is having a range, which is the oven is built in under the cooktop in a slide-in device. And the other 2 are whether you've got 1 or 2 wall ovens. The next one down are the 3 different versions of heat pump water heaters. The very tiny little bar there is the upcoming 120 volt heat pump water heater that can have a big tank and deliver a lot of hot water. Just takes longer during the day to recover while all that solar generated power is swamping the grid. The little heat pump water heater will be recharging its hot water tank. And then the other 2 are the ones Josie went over before, the 15 amp and 30 amp versions of the 240 volt heat pump water heaters. And then that big array at the bottom is the panel implications of, it looks like 7 different EV charger circuits. The invisible one at the top of that bottom stack is just using your garage outlet and plugging the regular trunk charger that comes with your EV, plugging it into the regular skill saw outlet in your garage. And that doesn't count on the panel calculations. And then these are all different, bigger and bigger circuits, getting down to the 50 amp circuit at the bottom, which really kind of swamps the electric panel And, that one's good if you do need to be charging, over 250 miles every night. But other than that, the others work quite well. Thanks.
Okay, so now that you've seen how easy it is, or what's involved at least in electrifying, you may be wondering what's stopping us from doing this. So there's a few things that Tom and I have sort of learned as we've been on this journey. So first of all, it's technically feasible. There's no new technology needed. There's all the products that we need are available today. In fact, I was doing some research. Heat pumps in the US today is already a $13 billion market. So there are parts of the country that are way more used to heat pumps than we are here in California. It's good for the climate. Electrification is good for our internal air quality as well as exterior air quality, good for our health, great for US energy security and independence. We don't have to worry about fossil fuel markets and prices going up because, whatever, there's problems elsewhere in the world. Electricity is generated here. You can't import or export electricity. So that's made domestically. And of course, electrification is good for future generations because it cuts down on carbon emissions and addresses climate change. So again, what's stopping us? I would say my impression is that the main barrier is just inertia. So we just are used to using gas devices in California. In fact, I would say our state is addicted to gas. California had natural gas pipelines going in as early as the 30s. And so all of our development just happened around natural gas. Like I said, other parts of the country are not this way. The Southeast doesn't have extensive natural gas pipeline infrastructure. So they're electric. Arizona, parts of the Southwest are all electric is much more typical. So it's something that's actually somewhat unique to California that we're just so addicted to gas. The other thing that Tom and I noticed is contractor resistance. For every 5 contractors you call, you might have 3 or 4 tell you that it's a terrible idea to try to move away from gas. So they're used to doing things one way, and not all of them are eager to make the change. There's also low public awareness that electrification is a solution to climate change. People who would tell you, if you asked, are you in favor of fracking, would say, absolutely not. I think it's terrible. And yet they are using, every time they turn on their heater, they're using fracked gas. So I'm not sure people kind of make the connection all the time. Also, some people are really interested if they're ready to take their first green, move to do something good for the environment, is they think rooftop solar. Tom and I tell them, no, don't do that. If you only have $10,000 to spend it on electrification. That's where you're going to have your highest impact on climate these days in San Mateo County, at least, where all of our electricity is carbon free. So just use that Peninsula Clean Energy, 100% carbon free electricity, and save that $10,000 you were going to spend on rooftop solar and use it to get rid of your gas. There's also public misperceptions. One of the ones we've been trying to address in this presentation, which is some people think electrification means you must do a panel increase or a utility service increase. It's not true. Then also people think that if they go all electric, then their home's going to be more vulnerable to grid outages. Well, I hate to tell you, but your furnace wasn't going to work in a grid outage. If you have a newer water heater, it wasn't going to work in a grid outage. Your dryer wasn't going to work in a grid outage. The only thing that might have worked in a grid outage would be your gas cooktop. And for those, for those situations, we recommend, making sure you have a propane camp stove. The idea that the gas home is so much more resilient in a grid outage is not necessarily true. There are some cities are kind of not used to providing permits for heat pumps. And so some of the permitting can be challenging. So that's something to look into for the town of Portola Valley. And then if people make a bad first move in electrification, like I mentioned, they get the 50 amp big kind of energy hog car charger, then they fill up all the space on the panel, and it makes the rest of their electrification difficult. So making that first move a smart move is really good. Keep the car chargers to like 20 amps, 30 amps max. And then of course we're up against the fossil fuel industry that's just, sees this addressing climate change as an existential threat to it. And so it's just fighting for survival by creating a lot of disinformation and doubt. It's even seeding, organizations that look like nonprofits arguing against electrification on the grounds that it's not affordable, but then it turns out it's funded by the fossil fuel industry. So there's just, there's a long history. The tobacco industry, they're sort of taking a lot of pages out of the playbook of the tobacco industry, but unfortunately they're very well funded and they're very organized, and they're really good at this. So anyway, so that is another barrier. But we do have some, good solutions to some of these barriers. Tom, you want to talk about the equipment guides?
Sure. Thanks, Josie. Yeah, so there are some great equipment guides like this retrofit guide that was sponsored by Menlo Spark, and Josie and I were both contributors to this book. It's put together for homeowners to take a look at and policymakers to get familiar with the electrification choices. It does go into this whole watt diet thing we talk about for panel optimization, and it has a lot of equipment guides in it. So you can see there in the slide, you'll be able to click that link and download it.
I can take this one.
Yes.
Yeah, so this is, one of the ways to avoid the missteps is to have a plan for your electrification. This is an example of some of the elements of the plans that Tom and I are doing for this county case studies project, where we actually do load calculations per the National Electrical Code. We write up a project list, here are all the elements, here are all the equipment that needs to be installed, and here are the details. We provide photos, existing photos of the house, so that the contractor doesn't actually have to come on site to bid the project. So anyway, this is an example of something we're trying to do to kind of lower some of those barriers to electrification for the homeowner. The plan also gives the homeowner kind of a guide, right? If they don't want to electrify all at once, maybe they're going to do it over time. It gives them a place where all of the information is in, it's all in one place. And it kind of shows them, if you get your circuits done, here's what you should anticipate, right? You should have a 20 amp circuit going to your water heater. You should have a 30 amp water circuit going to your EV charger location. So it kind of helps them think ahead, and so they don't run into that problem of kind of painting themselves into a corner and not having enough space on their panel. Okay, so pitfalls to avoid. I think we've mentioned these, the car chargers, not, picking sloppy equipment up front. Another pitfall to avoid is waiting for your gas appliance to fail. When the device fails, it's often Thanksgiving and there's people visiting and you're in a panic, and you may end up just having to go back to the gas device because you didn't pre-wire for electrification, for example. So, get all the wires in so that when that gas water heater dies, you're ready. You've got your plumber on, the plumber who is happy to install a heat pump water heater. You've got him on speed dial, so you're all ready. Or just be proactive and go ahead and get rid of the gas water heater and put the electric, but be proactive in what you do so you don't get stuck. One other pitfall to avoid is oversizing your HVAC equipment. A lot of HVAC installers do this because they do not want to get a call back by someone, from someone who's, that coldest day out of the year, just like a little bit chilly. So they oversize the systems, and, you just end up paying a lot more than you need to, and the systems can be less efficient when they're oversized. On the other hand, for your heat pump water heater, as I recommended, we do recommend oversizing the water heater. So don't undersize that. If you have a 40-gallon tank now, bump it up to 65 gallons or maybe even 80-gallon tank if you're going to a heat pump water heater, because it takes them longer to recover. So you want to have more hot water in storage. And it turns out now that the heat pump water heater tanks are very well insulated, so you won't take a big hit on your bill by going to a bigger tank. That used to be true in the past when the insulation was not as good. Okay, Tom, you want to end this, our last slide, on the benefits?
All right. So for the owner or the user, it's really getting a better controlled, advanced, modern device that gives you kind of more features and performance. And I really noticed with my heat pump, two things. One is I suddenly got cooling that I never had before in those, typically the second or third day of those heat waves would be pretty toasty in my house. But now I've got cooling from the heat pump. And then also during the winter, we get very steady, quiet, comfortable heat because the heat pump is a variable speed machine. It's got a nice digital control, and it kind of hones in on the right temperature and doesn't overshoot it. It's able to turn itself down so it just can maintain just the right temperature for me. It's also, these things are a lot safer. My induction cooktop can't catch anything on fire. Like my old gas cooktop could ignite things if I left them there, and it's a lot easier to clean. And you can even touch it right after you've used it, so there's no getting burnt on that thing. So there, good ideas to upgrade to these things that way. And then, for society, it's, I look at it as my generation has really laid up quite a bit of carbon legacy in the atmosphere. And it's about time we started these moves to pave the way for my daughter's generation so that we can, not burden her with too difficult a lifestyle. So, I just look at it as electrifying is the great way to do it. And so, if we're going to ask that people around the world do it, it seems like those of us in areas like Portola Valley and Menlo Park, we probably ought to be setting the trends and tackling these problems ahead of everyone else and trying to see, what is it like to scout out this path and try to catch up with the Southeast.
Good. So that's it. I'll pause there.
Great. Thank you so much, Josie and Tom. Fantastic. So I think we have time for some questions. What I'm going to ask is that people use the, if you look on your Zoom screen at the bottom, there's a thing called reactions, and that allows you to raise a hand. And if you could just raise a hand that way, then we can be sure you're unmuted and can ask a question. So do we have any questions? Dan Quinn has a question. Dan, let me ask you to unmute.
Okay, we're in Portola Valley Ranch. Our water heater and space heater are in a closet inside the house. So I presume we have a little bit of construction to do. We've got to build a little building or something outside, or somehow move all that plumbing and all that stuff.
Yeah, I'll try to tackle that.
Whatever. That's my question.
Yeah, so one of the ways to do it is not to build more things on there, but to use what we call split versions of heat pumps. And so I think Josie might have shown it in one of the pictures, but the heat pump often has this outdoor compressor unit. It's kind of shaped kind of like a suitcase, and it's got a fan and the compressor and refrigerant coils in it. So that can go outside without building anything out there. And then the refrigerant can go to an air handler that is the same size as your existing furnace. And this air handler has the fan like your furnace does, and a refrigerant coil that will either heat or cool the air, depending on the season. So that can go that way. And then also there are split versions of the water heater. I think in the picture we probably showed the unitary water heater that had the compressor unit built on top of the tank. But there, a company called Sanko makes one that's a split unit where there's an outdoor unit and a very quiet tank that doesn't need any airflow that stores the hot water. And then there's also a 120 volt version of that coming out on the market, but it's that 120 volt one only works down to about 40 Fahrenheit, and so may not work that well outdoors in Portola Valley. But the Senko unit works down to, I believe, -10 Fahrenheit. So it's going to do great in our weather. So that's one way to do it without rebuilding anything. Other things you can do, because like if you wanted to use the unitary type heat pump water heater, you could build a utility closet out there, but it would need a lot of ventilation because it wants to extract heat from the air. So if it were sealed in a tightly in a closet, it would just chill that whole closet down like a refrigerator, and then it would kick on its resistance elements to top off its temperature. So anyway, these problems are pretty surmountable, but you know, in some cases, like somebody has, say, a condo and their water heater's in the center closet and there's no way to get anywhere, they might want to use an electric resistance water heater. You know, it just takes more electricity, but you know, still with our carbon-free electricity, it's still okay for the climate.
Okay, so all I have to do is get my wiring done, and then I'm good to go when my water heater fails.
Yes.
Okay.
Yeah, you'll just need to pick a space for the 2 compressors and run your wiring to those locations.
Thank you.
All right. And then the other thing is, you know, these days with supply chain issues, it probably still doesn't make sense to try to ride your water heater to the bitter end. You might want to plan for some of these changes. And I've asked my wife about what is the maximum time we can go without a water heater, a cooktop, EV charger, and a furnace. And it was funny. It was 1 week for almost everything except indefinitely for the car charger, because she sees we could just plug our car into any, you know, we've got an outdoor outlet. But she said it was 2 days for the water heater. And so that tells me that you know, the water heater is the thing that holds my marriage together. That's the one I did proactively when my water heater turned 3 years old.
Great. I've got a question. So, I mean, there's the embodied energy content in an appliance or a car, right? I mean, it took a lot of energy to melt the metal and create that object. If you think about the life cycle impact of getting rid of something before its normal end of life, have people looked at that in terms of the energy payback? I mean, how much, I guess that's the question. I mean, is it best to just get rid of stuff, even if it ends up in a landfill, and you're buying a bunch of new metal?
It gets recycled. Yeah.
Well, okay,
All
right.
these big white goods, yeah, they get recycled. So the metal gets recycled and reformed back into useful things again. But yeah, it's best seen in a graph. Maybe we should make that graph sometime. But what you find is the emissions profile from running these fossil fired devices is the cumulative emissions from that device just keep going up and up. And there is no saving it all back again. It's just how far you ran it along there before something happened.
Yeah,
and
sure.
you went to this other one that has very low emissions, but like you said, did have an embodied
I guess that's
energy.
right.
They
You
all
already-
have embodied, yeah, they all have embodied energy. And out in Portola Valley, trust me, the air conditioner, central air conditioner, has all the embodied energy of a heat pump. It is a heat pump. It's just one that doesn't reverse.
Mhm.
And so, you know, well, lots of people out there are installing the one-way device when they should be installing the two-way device and get rid of the embodied energy of a furnace burner.
Yeah.
But
So
yeah, so
if I could comment on that, there was a pretty well-known study in the Wall Street Journal that looked at that for electric cars, right? And they looked at the life cycle analysis, and they found basically the idea that if your energy comes like right from solar for your electric car, then you're still going to take, you know, I think a year and a half to break even, right? From the cost of the energy required to produce the car, right? And so you're getting these new water heaters. So of course, this is much, much less energy than a car, both to build it and what you're using. So when we look at that graph that we have 8 more years to do this, I think that's a very good question that we say, well, if we have 8 more years to do this, but it's going to take, I don't know, 5 years or 3 years or 10 years to get this energy back, because it does take a substantial amount to create this new thing that you don't technically need yet. And I have a heat pump water heater. I think that's very useful data, because I think we have to do things that make a difference right now rather than make a difference. Maybe the net isn't for several years from now.
Great. Other questions? If anybody else who not a committee member, going to raise your hand with the reactions icon. If not, oh, there we have one. Christy, let me invite you to unmute.
Yes, I thought that was an excellent presentation. Thank you so much. I'm hoping you're recording this so the only 14 people are on and that the rest of Portola Valley could see it.
Yes, we are.
And will I be able to get these slides on the PV website?
Yes, we will figure out a way to make available both the video as well as the slides, which I guess I need to get the slides from you, Josie. That would be great. Yeah, because yeah, it's good suggestion, Christy. Thank you.
Thank you.
And then we have Ronnie. I will ask you to unmute.
Yeah, hi. Any tips on pool heaters?
Yeah, there are a bunch of heat pump pool heaters on the market. So they're electric. There's a Hayward, the guide that Tom mentioned, which will, when we send the slides, there'll be a link in there for the guide. But if you Google Redwood Energy electrification retrofit guide, there's a whole section on pool heaters. So check that out. But yes, a lot of the pool equipment brands offer, Pentair, I think, has a whole line of them, heat pump pool heaters.
Right. And they're much more common in other parts of the country than here. You know, like Josie was pointing out, California is kind of a gas fueled backwater, and the state has a long history of producing gas. You know, we were the major oil and gas producer neck and neck with Texas for quite a while. And so we have all this legacy gas. And so, you know, other parts of the country have moved ahead with heat pumps faster than our little technology center. It's kind of a nice irony.
Yeah, I think in California, we're so California centric. We like to think we're at the leading edge of everything. But in this way, we are not at the leading edge. We need to catch up.
Mm-hmm.
Great. Well, I think we probably should stop there, but I want to thank you again, both Josie and Tom. That was great.
Absolutely.
We appreciate it. And we're going to make this available to the whole community. So thanks again.
Thank you.
All right. Thank you.
So, and then if you want to stay and be part of our meeting longer than this, you're welcome to, but we could also, we would accept if you wanted to just disappear at this moment. Thank you again for attending though. Appreciate it.
Thank you.
Yeah. All right. All right, so we'll revert to, I'm going to stop the recording actually. I don't think we need to do, let's see. Yes, stop recording the cloud.